Hello and welcome to this video where I'm going to demonstrate the various performance counters that are available in NServiceBus. Let's start by just closing this and opening up the performance monitor. So we launch Perfmon and then add some counters. We select NServiceBus. And click OK. Oh, did something wrong here. And NServiceBus. No endpoint. So in order for performance counters to work, a endpoint must be running. So here's a sample that I'm now going to launch. And this sample is going to send a message every second, and processing of that message will take 100 milliseconds. So now endpoint is running. We go back to the performance monitor. Let's see if it's already is available now. I'll have to go back. And here we can see the instance now. We say add, and all of them should be available here. Let's remove some unneeded stuff. Processor time. So let's start with these because these are the most easiest to explain. Number of messages successfully processed per second, number of messages pulled from the input queue per second, and number of message failures per second. So on the normal conditions, when there are no errors, these two should be equal. So to indicate that, I'm going to increase the number of messages being sent. So I'm going to. So now every 100 milliseconds a message is being sent, basically 10 messages per second. So we go back here and we can actually see that the number of messages now is, well, it's a little bit less for some reason, but I guess that this line, let's enable the graph. Yeah, it's a little bit lower, probably due to some timing issues, but it's basically 10 messages per second. So that's good. And we can still see that the number of successfully processed messages per second is equal to that. So you can see a slight variation that is due to timing differences in how the performance monitor is measuring things, right? It's doing an average per second, and what the second exactly is, that's can be different. And this is currently 0. Which is obvious because currently I don't have any exceptions. Messages are just being processed. So if there would be failures, this would remain the same. And if there are failures, then this one, successfully processed messages per second, plus this one should be then equal to the number of messages pulled from the input queue. So for now, let's remove these. I don't know, maybe this is influencing the colors of the graph, I don't know. So let's remove these two from the graph. It's not really that interesting. That leaves us with critical time and service level agreement, or in short, SLA violation countdown. Let's first start with critical time. So when a message is being sent, it is being sent at a specific moment in time. The message is then first going through the NServiceBus outgoing pipeline. Then eventually the message ends up in the queue. It remains there until it's being fetched by a process. Then the process starts processing it. Eventually the processing completes, and that whole duration from creating that message until it's completely processed, that is what we call critical time. So here you can see that currently the critical time is 1. So we can go back to our application, and it's more or less for example, we can send a message every second, and now on average, because it's this number, the number is reported in seconds, so no precision in that. It's an integer. We can see that critical time is currently 0, meaning it is processed within half a second, basically. So let's increase the process duration. So we go to 1 second, and we should see that last is now 1. So now we go to 2 seconds, and critical time now is, oh, sorry, I have to, first go to 0. So now something interesting is going to happen. So eventually critical time is going to 2. But because message processing takes 1.5 seconds, it goes up. Why is that? Because we have a backlog of messages being built up in the queue. So if we go and look in the queue, we can see here that currently we have 11 messages, and this will be slowly increasing. Because the number of messages being sent to the queue is faster than the endpoint can process. So this indicates that the time for sending and completely being processed is now rising. And this can be an issue, of course, because maybe you want to make sure that messages will be processed within, as in this example, 100 seconds. This is where the SLA violation countdown comes in. Because if we take a look here, we see that its value. So what is this? What we're doing, we are reading, critical time is a fact. It's the duration of the last message being processed. Based on the last 10 messages, we are going to make an estimation. We're going to calculate how many messages the endpoint was able to process, what the average duration is to process a message, and based on the metadata of the first and the last message being of those samples, we can see how many, what basically the number of messages is sent to the queue. So we can see what the average number of messages sent to the queue. We know of the endpoint what the number of messages that's being received per second, and we know the average duration of each message. So with that information, we are able to extrapolate that into when we cannot meet our service level agreement. So to demonstrate that, we can first go back to this. Right, so now currently we can see that that we are sending one message each second, and that processing is fast enough. So if we now slightly ramp up the delay, right now for each 10 messages being processed, we see that there is a 1 second delay. So after 20 messages, we have a 2 second delay, and that's gradually increases. So if we take a look at the service level violation countdown, based on those last 10 messages, we should see that because the endpoint cannot keep up, that eventually this service level agreement will not be met. Currently, it's still being met because messages are still being processed within the SLA being specified. Right? The message being received, we know, okay, these can be processed. Critical time. Right? It's currently 8 seconds while the service level agreement is set to 100. But eventually, we will not be able to meet our SLA anymore. So if we take a look at our SLA violation countdown, we already see that it's sort of more or less declining. We can increase the process delay even a little bit more. And now we can see that this really has an impact. So once this line is reaching 0, that means that now we are in violation of our service level agreements. And that's not what we want, right? This means that that we have an issue. There are more messages coming in that we can process, and not only that, we know that if this is continuing, that eventually we cannot meet our service level agreements. So once we see that this high value is dropping, so just demonstrate that. Let's go back. So now the value of the graph is high. This means there is no issue at all. If we go back to here, we will see that the service level agreement is dropping. So this is an indicator that once we have this, that operations team should receive some kind of warning, or maybe not receive a notification. It depends a little bit on the environment, on the monitoring environment that you're using. Maybe you have just a dashboard, and this dashboard can show this value. So as long as you see more or less this, not really an issue until this line is suddenly declining, because this means we cannot keep up. So to make things worse, right? So currently we're sending just 1 message per second. And average processing time, let's keep it like this. So we have a processing duration of 1 second, sending of 1 second. So let's send in a little bit faster, right? So because now more orders are coming in per second. And so we suddenly have a peak of twice the number of orders being submitted to our endpoint than usual. So we see now that the service level agreement violation countdown is declining. And this will slowly go even further. This currently indicates that we are going to, at this moment in time, that in 150 seconds we are not going, our SLA level will be breached based on extrapolation. Because we know how many messages are currently being processed per second, and we know more or less how many messages are incoming. We don't take into account the actual number of messages in the queue. We don't know that. We only make an estimation based on the last 10 messages being processed. So here you can see that we will eventually not meet our SLA. And that's a serious issue, of course, if that's important for the business. So hopefully this demonstrates how these counters are working. So now what can we do to resolve this? So let's say we see this pattern. Right? We see that the service level agreement is not being met. We see that there are currently 2 messages per second being sent to our queue, while message processing takes 1 second. Well, what we can do is we can scale up our endpoint by increasing the concurrency level to 2. So let's do that. So let's first kill our endpoint, and then launch it again. And instead of 1, we say it's 2. Service level agreement is 100. We are not going to purge. And we should see here that now suddenly we are able to meet our service level agreement, because even though, delay to 100. Because even though we are sending twice as many orders and processing takes 1 second, we have a concurrency level of 2, meaning we can process 2 messages at the same time. So this would not be an issue at all. In this case, the number of messages being received is equal to the number of messages being processed per second. So of course this would be still be an issue if this would be higher, right? Because now slowly the critical time will be ramping up again. As you can see, it's currently 3, and will just slowly go up. So if processing is too slow, and you still have an issue. But in this case, this is perfectly fine for peaks, right? You have a short burst of incoming messages, and then this should not have any impact at all. As long as this value remains high enough, there will be no issue at all with your service level agreements for this specific endpoint. Okay, hope this demo was useful. See you next time.